Hi, I'm Alan Dev, and this is part 2 of my video about how to think like a scientist. In part 1, I explained what makes science special and described some of its limitations. Now I'm going to talk about how we can actually use science to learn new things. You might have sensed a bit of a contradiction in the first video. First, I argued that we can't really prove anything for sure except maybe our own existence, which doesn't seem to get us very far. But then I turned around and said that science can find out all sorts of universal facts. So if proving things is so impossibly hard, how the heck does science do it? Well, it turns out we can flip the whole problem upside down and focus on disproving things instead of proving them. Here's an example. Let's say we go to the park and see some white swans swimming in a pond. We take that observation and create a theory. All swans are white. Now, proving that theory would be really, really hard. We'd have to round up every single swan in the world and see if it's white. But what if we try to disprove the theory instead? That turns out to be a lot easier. All we have to do is go looking for swans that aren't white. As soon as we find one, we've disproven the original theory and have to come up with a new one. It doesn't matter how many white swans there are in the world. Finding one black one proves that they aren't all white. So maybe we can't really prove anything, but we can definitely disprove things, and it turns out that's almost as good. It's a bit like the old computer game Minesweeper. The game is all about figuring out where the mines aren't. As you uncover squares without mines, you eventually end up with a board showing where all the mines are. Each time you open up another square that doesn't have a mine, you also get a bunch of clues about where the mines might be. As you get more experience at the game, you make better and better guesses. Science is a sort of minesweeper for facts. We start by making an educated guess about how something works. We call that a theory or a hypothesis. Then we test it, which just means we try really, really hard to disprove it. If we can't disprove it, we plant a flag there and tell everyone else we think our hypothesis is right. Other scientists tend to treat that kind of thing like a challenge, so then they try to disprove it. Lather, rinse, repeat. Once it's been tested really well, we'll get pretty confident that our hypothesis is right and that we've found a new fact. If we do disprove a hypothesis, that's also great because it opens up a whole bunch of new possibilities and clues. When that happens, we modify the theory or throw it out and come up with a new one, and the process starts all over. It's an infinite loop. It's an algorithm that gradually uncovers more and more of the truth. And that's really all there is to the scientific method. What's that? Oh, yeah, excellent question. If we're constantly trying to disprove theories, how can we ever be sure we're done? The short answer is that we can't. That's why there are no absolute laws in science. Yeah, I know, we say things like Newton's laws of motion or the laws of thermodynamics, but that's just a historical glitch. Those are technically all theories that might still be modified someday. In fact, it's already happened. For example, a couple hundred years after Isaac Newton died, a guy named Albert Einstein came along and proved that Newton's laws were wrong. Well, not wrong exactly, but not 100% right either. It turns out that Newton's laws of motion work great for the things we interact with every day, but not so well for stuff that's ridiculously small, like an atom, or moving ridiculously fast, like pieces of an exploding star. So Einstein's theory of special relativity is an add-on that explains things Newton didn't know about. And even though Einstein was humble enough to call it a theory, it's no less valid than Newton's so-called laws. It's a bug fix for an older version of physics. In fact, that's a good way to think of science in general. It's a continuous series of software updates. There's always a new version coming out because we're always finding new features we need or errors to fix. That doesn't mean the current version is bad, just that it can always be made better. You can build an airplane or fire a cannon with nothing but Newtonian physics, but the Einstein update lets you make spaceships and nuclear bombs. So that's science. Come up with a theory to explain how something works, try to disprove it, then modify the theory if necessary, and test it again. When you've eliminated everything that's definitely not true, you're left with the truth, at least within the limits of your tests. As you probably realize, this process can get pretty messy, at least if you do it right. People sometimes get emotional about theories, and to paraphrase Jack Nicholson, we can't always handle the truth. In future videos, I'll discuss how we can balance scientific skepticism with open-mindedness, suggest some ways to control our biases, and talk about how we can check scientific claims when we can't do the experiments ourselves. Thanks for watching. See you next time.